going on, guys? Johnny Bannon here with Trepa Technologies, and in this video, we're going to be going over domain 1.1 of our CASP self-paced course. So in this video, we're going to cover load balancers, IDS, IPS systems, and then we're going to end going over web application firewalls. So this is going to be part of domain 1.1 secure network architecture for the CAS-004 exam. So let's go ahead and get started. We're going to go over domain 1.1 secure network architecture. So here we're just going to go over the different types of hardware appliances that can either sit in line on our network or be software based. That's going to help protect and give us that defense in depth to our enterprise. So I just want to start off by going over a few key concepts when we talk about security, since we kind of just jump into hardware, right? First thing I want to go over is, of course, the CIA triad. And when we talk about the CIA triad in terms of security, we like to define all three acronyms. Or all three letters in that acronym. So the C stands for confidentiality. The I, integrity. And then A, availability. So when we break these words down, when we talk about confidentiality, how do we provide that to our enterprise? Well, we could do that with access control. And we can do that with encryption. So this is how we protect our data. We can protect our data in transit. We can protect our data at rest. And we can also protect our data in use. That's when we talk about like memory, RAM, and compute resources in our computer, okay? So now bring this full circle back to domain 1 network architecture. When we bring up things like load balancers, you may be thinking, well, what innately in a load balancer provides us cybersecurity protections? Well, it's not going to do encryption or access control for us, but what it can do is give us something called availability. And the reason I like to break confidentiality down first is because that's what people think of when they think cybersecurity. They think, okay, I'm protecting my network from hackers, which is a big part of cybersecurity, but it's not the full picture. As cybersecurity engineers, as SOC analysts, as architects, we have to take the entire enterprise into account. And if you're taking the CASP exam, that's because you feel you're ready for a role that's a little higher. Maybe you're the SOC director. Maybe you're trying for that CISO role or CISO role. Maybe you're going for cybersecurity architect level 3, or however your company wants to label it, but something senior in cybersecurity. Now we talk integrity. We're going to talk things like hashing technologies and non-repudiation. Stuff like digital signatures. And then availability. This is where we get into resilience on our network. This is where we get into redundancy. And then to bring it kind of real world, just to get away from the vocabulary of CompTIA exams, are our systems highly available for our users? Are we so locked down and have so many security measures that it's making profitability slow down, right? Because as cybersecurity professionals, as IT people in our organizations, we're there for really one purpose, and that is to enable business operations. So when we start to implement new technologies, new safeguards, we start to build our defense in depth, it's important that we make sure that our organization, one, has the appetite for it. Are they willing to invest the money into really locked down and maybe like a zero trust architecture and a lot of good cybersecurity principles and functionality and equipment? Or are we always fighting an uphill battle? Do we not place cybersecurity as a priority? And depending on the organization, sometimes they won't, right? So it's your job to enable the business operations and to meet stakeholder demands, right? And whether that be all your customers, anybody that in the business that has a stake in making it a success, right? You're there to enable them. And that includes yourself. So now let's actually dive into some cybersecurity architecture, or what they call it. What's domain 1? Yeah, secured network architecture. So the first thing we're going to talk about is a load balancer. So this is going to be either software enabled or an actual hardware product that distributes connections to a server or appliance to ease a heavy load, okay? So right here we have our diagram, and essentially what this load balancer is doing is kind of also acting like a reverse proxy in a sense that when we have TCP connections come in here, they're going to connect to this load balancer, and then it's going to distribute it out to our multiple different web servers that we could possibly have in that web server farm. So what does this load balancer provide us? Well, one, it's going to provide us with what? Redundancy. Because we're able now to have these, let's say, server 1, server 2, operate in an architecture where they look like a single server, because now that user knows it's just using this, what we would call VI, or this public IP, to connect to this web server. Maybe this is trepatech.com, right? And then shared between these web servers is going to be something called a virtual IP that they all connect to, right, on that load balancer. Now, when we talk about load balancers, we also do have some cybersecurity protections along with it. Load balancers can help us alleviate DDoS attacks, distributed denial of service attacks. This could be stuff like SYN flood attacks, especially if we're talking like a web server where we just keep sending those SYN flags as initiated connection, but we don't actually connect. So when we start TCP connections on our server, that's using compute resources like your CPU, and then it could bog it down, right? So that's like a distributed denial of service attack. Or maybe that NIC can't handle all those connections that's on the server. So our load balancer can alleviate things like that. Now, when it comes to how that load balancer can function, there's going to be a ton of different algorithms that we're not going to dive too deep into in this slide, but these algorithms affect the scheduling. And we talk scheduling, that means, okay, when we have inbound connections to us as a load balancer, how do we actually distribute the load? Are we going to do something like a round robin where we don't take into account any metrics? We're just sending it to 1, 2, 3, and then down the list again, right? Or do we do more agent-based communication where we have that server and that the web servers communicating to us, the load balancer, and saying, hey, my CPU threshold's at this. I have these 10 active connections. One of them is doing a huge file download. So send those new connections to server 2. So we can have more like heuristic-based, right? Where we actually are using some sort of metric determination on what web server we should send these connections out to. So when do you deploy a load balancer? Well, again, it kind of depends on your architecture. So let's go through the different ranges of businesses. So if we have a small business, what kind of architecture are we looking at? We probably may just have like a router. They may maybe have a dedicated firewall. And then they maybe have 20, actually no, a small business, they maybe have 10 to 20 users. And those users are probably just using all SaaS-based stuff. And when I say SaaS, what do I mean? So software as a service, right? So this is kind of getting into our hybrid architectures. And this is something you have to understand as a cybersecurity engineer of the future, is that it's not so plain and simple, right? We don't have businesses now that just have a bunch of on-prem servers that you're going to have to use load balancing for. So maybe we just have a router, maybe 2 switches, maybe we're in a small strip mall, right? Maybe we do a turf company and we have like 8 salesmen and then 6 guys in the warehouse. So we give them user accounts, but we're not really online. So then we have our computers here, we have our VoIP systems, and then all of our CRM platforms, our customer relationship management platforms, are off here in the cloud, okay? So here, if we were worried about denial of service attacks on our services, meaning what servers do we use to give us profitability? Well, if we are that turf company, that our salesmen, right? They're the ones that are making us money. Or we have a warehouse that has IoT devices that are also grabbing their services and using their applications in the cloud. Well, then maybe we're thinking about putting a load balancer up in the cloud, which is possible. So maybe now we think about cloud-based load balancers to make sure that we have redundancy and high availability for our users. Okay? So now just let's expand this. So now let's say we move into a medium-sized business or a large enterprise. Well, now maybe with the large enterprise, so if I change these to distro switches, we have our 3-tier core topology, core distro, and then we have a web server farm out here that we're also leaving public also as well. So our users can hit this publicly, or maybe they have to use a VPN into our enterprise to hit these web server farms that, let's say they have our SharePoint portal. Maybe now we start thinking, okay, do we put a load balancer in line there? Something we always got to account for too, if we're ever getting hired to consult or to be that cybersecurity engineer, is growth. If our company has a 5-year growth model, do you want to be reactive or proactive to that growth? So maybe then we start thinking about load balancing, especially let's say we're doing e-commerce. Now we have those dedicated servers, maybe sitting in a data center or cloud-based. Maybe we just do the load balancing if not needed until it is, right? And what do we mean by that? So we're talking like scalability and load balancing. That's the network architecture we're going over now. We have peak seasons depending on what industry we work in. So the major industries, right, that we could be cybersecurity professionals in: health, finance, right, government, and then really is retail, big retail chains, right? Like even like something like TJ Maxx, they have a cybersecurity department, right? Amazon, if you still kind of consider that a retailer, even though they have AWS, right? So they're in the cloud. But to the common person, the everyday person, AWS definitely has a cybersecurity team as well for their retail, okay? If you're in this major industry, you're going to have peak seasons. And there's going to be times when you have to horizontally or vertically scale your resources at pace with the consumption. So with all the users trying to buy your stuff. Maybe then we start thinking about, do we deploy load balancers all year round or just for those peak seasons? And when we come to that conversation, we have to, again, enable the business correctly. We're there to make a profit. We start to think about operational expense versus capital expense. I'm just going to leave CapEx. So operational expense, it's called OpEx, CapEx. So if we have cloud-based resources, that's going to be an operational expense that we have to account for, right? We're going to deploy load balancers and nothing's free in the cloud, so that's going to cost us something. We're talking capital expenditures. Maybe we're such a big retailer that now it's cheaper for us to deploy an on-prem web services, deploy CDNs, do caching worldwide, and then have load balancers at our data center. And now we're getting into our capital expense. What's it going to cost us to maintain that load balancer year round? Because if we're doing on-prem, we don't have the ability to just go and deploy something via a cloud console and then delete it once we no longer have that need, right? Capital expenses, if I deploy a load balancer in this data center, that's going to have to sit there year round. What's going to be my human cost, right? Do I have to train somebody? Do I have to bring someone on that's dedicated to this stuff? And then what's my, again, capital expense? What's the power resources in that data center it's going to take up? What if it goes offline? Now do I have to buy 2 load balancers? Am I going to have some vendor neutrality? Am I going to have to go to a VAR, an authorized reseller, right? Just all these different things that come into play for just deploying a load balancer, right? So we can make this really complicated, especially for our large enterprises, and we should. Because if we go deploy something like this, we want to make sure it's enabling the business properly, that there is a need, and we're not just getting what I like to call tech fancy, right? Where we learn something, we want to go deploy it right away. Okay, so that's load balancers. Next, we're going to go over IDS systems and IPS systems, okay? So intrusion detection, intrusion prevention systems, they're typically going to be deployed in the same way. Meaning when we architecture these out, when we build our network diagrams, and we plan to deploy this capability, it's either going to be in a line right here as an actual hardware appliance, or it's just going to be part of like the software suite of features in that router, okay? So an example of this, let me bring this up over here on the side. I use Ubiquiti, right? So my Ubiquiti router that I use at my house or at my office, it has network intrusion detection built into this, right? So I can build network intrusion prevention detection into this, and it's not an additional hardware appliance. It's just a part of the features that come with this internet-facing router, okay? So when you see those arrows there, yes, it could be anywhere. Now, we could have this on the outside perimeter. We could have this on the inside. If we have it on the outside perimeter, that could be a way for us to detect people trying to DDoS us. Like imagine if this router was just doing routing. So then this NIDS was on the inside. We could never really detect if we didn't have any additional feature there, if we had DDoS attacks getting filtered at that demarcation point or that customer edge right there for our router, okay? Now we put it on the outside perimeter. Typically, this will also be like an all-in-one appliance. This NIS that sits on the outside, probably going to be part of like a firewall solution, right? Especially with these advanced firewalls that are integrating AI at a rapid pace, integrating a bunch of feature-heavy things, or not just filtering based off layer 3 and layer 4. More than likely, we'll have some sort of IDS or IPS system in there, okay? So that's the network intrusion detection and prevention. Now let's kind of dive into those two different terms. So detection, all it's going to do is just alert you, okay? It's not going to be able to actually prevent or stop any malicious attacks. So now let's get into configuration of that alerting. How are we going to create these alerts, okay? Well, when we start thinking about how we want to be alerted, there's going to be a couple key things. One, our scanning flags. Two, the transmission. How do we want to be alerted, as in, are we going to have SMS? Email? Is it going to go to maybe something like Slack or maybe our Skype? So the transmission, right? And then the scanning flags, this is going to be like false positive, false negative, and then we have true positive and true negative. Okay, so what are we talking about here? Well, one, we have to configure how it's going to scan and how it's going to determine when something is potentially malicious, like network traffic is malicious. So how do we even start there? Well, there's a couple different ways we can do our scanning. We can make it, I'm going to put a little arrow down here. We can make it heuristics based. We can make it signature based. We can enable some ML and AI to create a user baseline or a pattern of behavior, and then set up alerting from there when something deviates from that baseline to alert us. So let's go over heuristic base. So this is going to be a combination of things, and these two kind of like go hand in hand. Nowadays, with AI just coming on the forefront, they like to, for marketing reasons, say something is specifically AI, right? But it's kind of been doing this. With heuristic base, you're going over how the network typically looks. Is there going to be strange files coming in? And that kind of wraps it all into one and says, okay, I believe there may be something different here. So the ML and AI user baseline and pattern behavior is essentially doing the same thing, except when you specifically call it machine learning, now we're getting to an actual ML algorithm that's going to be enabled on that device you're scanning for. And then signature based, that's a very common one. So that's essentially saying, okay, we have these known viruses that have a signature, that have a hash to it. We can scan our network for those hashes, and if we see one that's been used or it's been out there in the world in the past, we'll set up an alert, okay? So that kind of relies on already known information. Well, this can kind of intelligently make decisions, right? When you have that heuristic-based or AI user baseline pattern behavior established, now intelligently we can say, hey, we see some data exfiltration. That could either be malicious or non-malicious. Either way, let's send up a flag so that our security team can now monitor this, okay? Now let's go over those scanning flags. So a false positive is obviously going to be when our system alerts us and there's nothing there. A false negative is when nothing happens. Essentially, it just means like, yeah, we're good. So we do our weekly scans, we do our weekly log audits, right? Diving into the logs in our security operations center, and we're like, yeah, nothing happened this week. A true positive is ding, ding, ding. We got a cybersecurity incident. Let's start our incident response plan, okay? And then a true negative is when we didn't even see it and it didn't alert us, but there is something malicious going on there, okay? That is a true negative, all right? Actually, excuse me, guys. I got that mixed up. Switch the definitions there, okay? A false negative is when, sorry, sometimes I get a little mixed up, right? That's just the danger of going ahead of your slides. The false negative is when there actually is something malicious and your systems didn't catch it. A true negative is, yes, there is nothing going on here, okay? Everything's good to go, all right? Whew, okay, so that's intrusion, detection, and prevention is going to do the same thing, except now the third thing that's going to be added with prevention, IPS, is your run books or your playbooks that you're going to have configured that are actually going to take action now. They're actually going to stop what your system may deem as malicious transmission, maybe data exfiltration, or a virus trying to get access on your network, or like a worm, right? Some self-propagating virus. So that's going to be the actual action it takes. What do we have to worry about here, guys? We have to worry about it actually like false positives, right? If we have intrusion prevention systems that are highly sensitive, that could affect the what in our CIA triad. That could affect the availability. Well, now we're stopping things that aren't malicious, but because our ML and our AI user baseline pattern behavior recognition is so sensitive, now we are, okay? So we just have to be careful when implementing IPS. Now, a fourth thing you have to realize when you're implementing any system that's supposed to do deep packet inspection, so this isn't just for IDS and IPS, this is for any system that does deep packet inspection, you're going to have to make sure that you're doing TLS inspection on it. So let's think about this, guys. When we have that client to server architecture, so in between here is going to be our ISP, our enterprise network, right? Let's just look at the flow of when our users connect to a web server. They're always going to use HTTPS, of course, right? And we're going to probably enforce that by adding some HTTP headers into our lockdown web browser, of course, right? So we have good defense in depth. Well, when they do that HTTPS connection, it's encrypted. So if I have an IDS system here, how can it do deep packet inspection if that payload's encrypted? Well, what you have to do is actually install some SSL certs on here. There's my little lock that can actually decrypt it, inspect it, and then re-encrypt it and forward it to its final destination, okay? So something you have to realize is doing TLS inspection should be the standard, because if you don't, you aren't actually properly detecting anything. If like an advanced persistent threat or a hacker is in your network doing data exfiltration, it's going to be encrypted. Now, you may be able to do network scans and see some ports open, but it's just always best practice to do that TLS inspection when we have any device doing deep packet inspection on our network, okay? Now, last thing we're going to cover. So I just talked about network intrusion and network intrusion prevention systems, but we have other kinds like wireless and also host-based, okay? I'm not going to dive deep into the host-based because believe in domain 3, we're going to dive into that. But the principles are still the same. With a detection system, whether it's on the network, it's on your host, or it's wireless, it's just alerting you of something potentially malicious. Now, intrusion prevention systems, whether that be on the network, whether that be wireless or host-based, it's going to detect and also prevent and stop security events in the enterprise. It's also going to alert you as well, but the main difference is that a NIPS, a HIPS, or a WIPS is going to prevent something malicious from happening. So more that proactive approach, right? Okay, and don't worry, guys, I'm recording this. So if it seemed like long-winded and deep, you can always go back and watch. All right, web application firewalls. So these are going to be firewalls that specifically prevent security threats over an HTTP conversation. So an HTTP conversation, that's going to be when we're doing, right, of course, HTTP requests from client to server, a web server, and we're going to be wary of attacks like cross-site scripting, SQL injection, any sort of injection attacks, okay? So with the web application firewall, that can be deployed via cloud, inline, or as a feature on the actual web server itself, which I don't really recommend. Like, you want to probably put that as part of, like, if you have a firewall, make sure it's doing web application firewall. And in the cloud, this is kind of like the standard, right? Web application firewalls. So what's the whole purpose of this? Just to monitor your HTTP connections. So it's not going to be looking at like FTP. It's not going to be looking at anything else that connects to your web server, just HTTP. Now, there could be web application firewalls that could, again, get a little bit more advanced. And they're like, oh, well, we'll monitor SSH or Telnet if you have other open vulnerable ports. But then it's kind of like, is that a web application firewall? Or is that just a secure web gateway? You know, there's different things, purpose-built things, right? So one of the things I like to bring up when we talk about this is a website called OWASP. So that's going to be the open the OWASP Foundation, the open source foundation for protecting web servers and your websites. So web application firewall, pretty much you can say, okay, these are all my web-based attacks. This is what a web application firewall should protect me from, especially if the attack is initiated from actual HTTP, right? Obviously, like insecure design, like that's on you, the administrator. You deploy a web server, make sure you have hardened web servers, right? So you can always, we're going to talk about this later, but if you're looking at what you want protection from when it's